Okay, we'll begin our demonstrations on using functions by looking at some numeric functions. And you might already be familiar with some of the aggregate functions, and we have seen a few examples. The sum function, for example, seems to be rather numeric, but officially that is an aggregate function. It operates against a collection, whereas numeric functions are more so just straight up math. So if you have a very mathematical based database, you would often see these functions used. So we'll begin with the round function, and this is used to simply round up or down a value depending on what its value is, and I'll come back to that in a moment. But before we see the syntax, what I've done here is to select out the amount from the payment table, and you can see that in every case it ends in 0.99. Well, maybe we just don't care about seeing those decimal places. I want to see the rounded value. So we can select round as the function, and anything a function operates on always goes in parentheses. In this case, it's operating on the amount column from the payment table. So let's execute, and we see the rounded values. Now, the algorithm that rounding uses is that if it's 0.5 or higher, it will round up. If it's below 0.5, so 0.49 or lower, it will round down. Okay? Now, you can also control the number of decimal places. So if, for example, I have many decimal places for a very precise number, I can say, well, only show me 1 or 2 or 3 or however many you want. So in fact, if I did want to see one decimal place, I could put a comma after the amount and then the number 1. Re-execute, and we do see one decimal place, but it still rounds up. But watch what happens if I go with 2 decimal places. In this case, it doesn't really round at all because I explicitly told it to show me the 2 decimal places. But had there been, let's say, 5 or 6 decimal places, it would still round up or down accordingly, and then only display however many you tell it to display. So of course, the results are dependent on what the actual value is, but if you just specify nothing in terms of the decimal places, it always rounds to the whole number. The power function raises a value to a specified exponent. So in this case, I'm selecting POW for power. This is the initial value. This is the exponent, and it can be any exponent. So in this case, if I were to execute this, 10 to the power of 3 is 1,000. There's the answer. And of course, you could put in a column value here. It does not need to be an explicit value. It can be just about anything. And then the ceiling function returns the highest whole integer above a specified value. So in this case, I'm passing in 1.567. Ceiling will say that the next whole integer above that is 2. So let's go ahead and execute that. And sure enough, 2. And the floor function does the exact opposite. Same value. This returns the lowest whole integer, which in this case is 1. Now, that's fairly easy to discern just by looking at it, so you might think, well, why bother? But it would be when you're comparing a value. I'm not interested in using the specific value of 1.567. 2 will suffice. So anything that is 2 or higher, for example, will come back, or 1 or lower might come back. So commonly used again in comparison operations. But those are some examples of numeric functions. And I should point out that there are quite a lot of these. So again, if you do have a very math-oriented database, then I do suggest a little more research on the numeric functions. I think there are more than 20 or 30 total numeric functions, so it wouldn't hurt to look those up. But they can definitely help you with some calculations and manipulating numeric values.